Thank you for that introduction, Gabriele.
Thank you.
Welcome, everyone. It's so cool to see so many people excited about WebXR. And it's a really exciting time for WebXR because we just managed to show that WebXR performance can match performance of native apps. And we did that by porting a native MetaQuest 2 game onto the web. Let's start with a trailer.
Hello? I used to worry about nightmares in my sleep. This nightmare is endless, like a circle. But cycles can be broken.
I hope you enjoyed that. It was a little hard to see, so make sure to check it out in the social media channels. Today I'm joined by Timmy Kokke, who is also known as SourceCode. He's the main developer working on this project and a WebXR solution architect at Wonderland. And I'm Jonathan Hale, the CEO and founder of Wonderland. And I'm gonna start opening this presentation by giving you a little bit of a foundation. What is WebXR? Why would you even port a native experience onto the web? How does it work? Timmy is then going to cover the development process of Dead Secret Circle on the web, what we've learned from it, and what we had to do. And finally, I'm going to wrap up the talk with a short summary and an outlook. OK, so why would you port a native app onto the web? WebXR is basically just VR and AR on the web. That means it's served via websites and inherits all the properties, all the advantages of websites and web apps, which are, it's an open platform. So you do not have to ask for anyone's permission to publish. You just take your web files and you publish them to a web server, and then you have a link. And that link can be shared. It can be shared via social media, via a website, via a QR code. And then people can just scan the QR code or click on the link and immediately jump into the experience. So it's very accessible. There's a very low barrier of entry. No downloads or installation necessary. But my favorite and absolutely most awesome advantage of WebXR is that it's cross-platform. And you'll note it's so cross-platform, I even snuck in a Quest 3 Lite in there. And the Apple Vision Pro is there, of course, too, because it can even support future devices that you know will support WebXR on the browser. You'll be hard-pressed to find a manufacturer that doesn't support WebXR yet. These are the companies that support WebXR today. But cross-platform doesn't even stop at XR. It goes beyond it to desktop and mobile. So you can still target a broad audience of people that might not have onboarded to the spatial computing platforms yet. So this sounds a little bit like OpenXR, right? And it is similar, but there are some key differences. They're both display and input abstractions, but OpenXR is still an installed native app, which means you are OS dependent and have to repackage the game for every system you want to support. WebXR, on the other hand, is a website. That means it runs everywhere, one single OS-independent app on all of the devices. So how does this work? Sounds a little bit like magic, right? Effectively, the browsers are responsible for exposing the native APIs of the systems via standardized web APIs. And these web APIs are consumed by a framework like Wonderland Engine to then run your XR app on the web page. So if you want to get started with WebXR, here's how it would work. You would use one of many, many frameworks, produce a bunch of web files, and upload them to a static web host of your choice. And then you have a link that you can share. The frameworks can be categorized into roughly 3 different batches. One are code-only frameworks, so frameworks that literally write everything in code, even the scene setup. Then we have cloud-based engines that come with a visual editor and usually come with cloud space attached. And finally, we have development platforms, native applications that you install and that produce the web files for you that you can then upload to a web server. And of course, this is a sponsored talk, so I'll go into detail with my favorite one. Wonderland Engine is a development platform for VR, AR, and 3D on the web. Because it's web, we support all of the devices. It's made for web, so our JavaScript API allows integrating with any web API or web service and any JavaScript library. The workflow is ridiculously fast, so you can package even large projects in less than a second. And finally, we are optimized for the specific performance characteristics of the browser. That means with WebAssembly and optimized WebGL 2, we can even run native-like experiences on the web. And that's exactly what we did when we partnered with Robot Invader, the developers of Dead Secret Circle, to bring it on the web. And Timmy is going to tell you all about that.
Yes, thank you. So I'm Timmy. I'm one of the developers that worked on porting Dead Secret Circle to the web. And I'm going to take you on a short journey on what we had to do to make that possible. I'm going to talk a little bit about the workflow we followed, what we did for coding, some optimizations we had to do. And we were very lucky to have access to all the assets from the original game. We got a Unity project where everything was in. The unoptimized assets, as well as the optimized assets for VR. We exported those to Blender just to make sure everything was all right, fine-tune some things here and there, and then we exported things over to Wonderland Engine. One of the things to note is that at some point the Blender files turned out to be very, very big. The blend file for the scene you saw in the video with the elevator was well over 1 gigabyte in size, mainly due to the uncompressed textures that were in there. After exporting, compressing everything, and having Wonderland optimize everything, the entire game is now 150 megabytes. We noticed that there were some meshes in the Wonderland scene that were not being used, which led to the developers of the engine building an update to remove those from the package, so that even reduced the size even further. Now let me note that you don't need Unity to build games with Wonderland. You don't even need Blender for that matter. But there are some uses of Unity that can be very helpful. The original game is very atmospheric. It looks amazing. It's a bit dark, but as you can see, there's a lot of lighting going on. Now, lighting takes a lot of computing power to calculate when running a game. So what you can do is do that calculations up front and then use that data later. And that's where Unity comes in. It's very easy to create the light maps in Unity, so all the calculations are done up front. And that way you can keep your high details in, for example, the tiles in the bathroom or the wood grains on the ground, and repeat that texture when needed, and have a layer of lighting information on top of that. This is an example of one of the light maps used in the game. This is calculated by Unity. You don't have to do that yourself. All the UV coordinates that are being used are done by Unity. Now, to export this, we used an open source project by Mimlotsky, because the default exporter does not include the light maps. Yeah. So, as an example, I took that bathroom scene and removed the light map so you can see the difference. Now, this looks pretty good for a game built in the last century. But if you add the light map, you have an instant atmosphere going on in that scene. All our coding was done in TypeScript. TypeScript compiles down to JavaScript, so it runs in every browser. And Wonderland supports both JavaScript and TypeScript. The main benefit of TypeScript is that the code base is pretty large for this game. And with TypeScript, you get some time checking, which helps you in your IDE when coding. It gives you errors, and you can find bugs really early into the development process and not when the game is in production. One other great feature of Wonderland is that it's updating instantly when you change your code. So in this quick example, I add a property to to a component, and as soon as I hit save, you see on the other side that the property is automatically added. There is no editing trickery going on. This is just a screen capture to show what's going on. A similar thing happens when you package your project. When you package your project, it's automatically updating a browser window, either on your desktop or even on the Quest when you use one of those. And that way, you don't have to wait tens of minutes to compile shaders and package everything up and deploy it to your device, and then come to the conclusion that you packaged the wrong scene or did something wrong and you have to do it all over again. With this workflow, it's just instant. You package and you can run it. We did write a lot of custom components. Unity exists for a long time, has a vast majority of components available to everybody. We had to write everything by ourselves. There is no large community with 1 million components or marketplace yet. But in the end, that will be great for our users as well, because most of the components that are reusable in this project will flow into other libraries and for everybody to use eventually. Wonderland already does a great deal of optimizing for overdraw. Overdraw is when you have objects, for example, 10 objects that are on top of each other in your view, and you start with the last one for the rendering. That pixel has to go through some calculations before it's drawn on the screen, and if it's in the wrong order, you have like 10 different times you need to calculate for that one pixel. If you want to optimize for that, you can reverse that and only draw the first one. Wonderland has a nice overlay to identify possible issues, and they show up more red in this case. The performance of the application was pretty good from the beginning, but nevertheless we kept an eye on the performance throughout the development, using the built-in profiler as well as the profiler in the browser. This way we can find memory leaks, for example, or times when I would just initiate some property in the update cycle and just screw up the performance. For publishing, we have a continuous integration pipeline set up that every time we merge our code to the main branch, an automatic build kicks in and deploys to an internal website so we can test it. And as soon as we tag the main branch with a version number, another build kicks off and deploys automatically to itch.io and to HeyVR. If you want to know how to do this yourself, we have a nice tutorial on our website to take you through this. And it's not only for GitLab, it works on GitHub as well. Jonathan mentioned it in the beginning. I want to mention it again because it's a big one, I think. The game runs everywhere. You just build once. It runs on standalone devices, non-standalone devices, and on a desktop. We gave a little bit of extra love to the desktop version so that the mouse cursor changes in the same way it does in VR, for example. And with that, I want to hand it over back to you, Jonathan.
Awesome. Thank you very much, Timmy. So we've heard WebXR comes with some amazing benefits, namely it's easy to publish, super fast to access, and it's shareable. But most important of all, it's cross-platform, so much so that it even supports desktop and mobile. We've learned that it's totally possible to convert native to WebXR. The performance is already there and available. And the future is the web. And we've come to show you this at our booth with two more experiences. The Escape Artist by Pardowski Creative launches today here at AWE, so you can be one of the first to try it out at our booth. And we also brought recently announced Archery Evolution. WebXR brought a small preview project for you to try. Do really come by the booth because the Escape Artist has an unprecedented depth in narrative, in art style, and in polished VR interaction. Here's some impressions on that. Where is the booth, you might ask, right? Booth 263 is right when you go from the entrance straight, and then you'll find it on the right. And be sure to be there today at 3:30 because we're giving out some free coffee. And we'll have a WebXR meetup there. Please scan this QR code if you want a calendar invite, otherwise just stop by. 3:30 p.m., super important. And with that, thank you very, very much for your attention, and we're happy to take any of your questions. Very well done.
So thank you very much, Guy. I think there was one of the things that stood up with me is the fact you don't need to ask for anybody for your project to be published. That is something that was not even always stated, but I think it's great. Thank you very much. And I think there are right now a lot of opportunities for WebXR. I see a question. Please, do we have a mic? Mic, otherwise you can talk louder.
Yeah, I can talk louder. Is it loud enough?
Yeah, go ahead. The microphone is coming, though. It's behind you.
Hello, my name is Thomas. I have a platform which is built in A-frame, and my question is, we do in real time reading data from a data source. How would that look like with your platform? That you really change it from a, let's say, a GraphQL database or similar thing while you walk through the game?
You ask if it's possible to include...
Yeah, how you do that? Because you package the whole stuff somewhere on a CDN or a URL where everything is pre-packaged like I understood it so far. And how would you do real-time updates then?
Okay, if I understand correctly, you're asking if you can include external sources in your application?
Yes.
It is basically just a website. There is a big part of it is optimized,
yeah.
But you can do anything that the web can do with your game as well. You can do calls to other things. It is just a website with some fancy things going on.
Okay.
But you can call any service you want.
Yep.
Another question there.
Hi, my name is Asbjørn. I come from the Danish startup Udo. My question is more regards if you port your VR or AI experience to mobile or PC, how do you control these experiences?
What do you mean by control?
So, for example, most VR headsets today uses either controllers or hand gesture recognition. So if I play a game on my PC that has been ported through the web, or if I run it on mobile and it's not in a cardboard VR experience, how do I control it?
You do have to handle any different type of input. In this case, we were lucky that the game was designed for PC and VR in mind, so you control everything with a cursor, basically, like a point-and-click style. and therefore it also runs really well on PC. And we just took the interactions they had designed for this case. If you build a new game and want to support PC and VR, obviously you would want to probably have keyboard input for PC and handle that separately, while you have the controller input for VR. And if you want to support the Google Cardboard, then you'll want to somehow find some interaction that works with just a simple tap.
Great. I think I might have something interesting to show you later.
Sure, happy to talk.
More questions? Let's go behind you maybe, and then we end to the left.
Hi, I'm Thomas. Thanks for the great speech. I have a question. Since you can also deploy out of Unity to the web, why is it an advantage to use your engine, and what about the performance compared to Unity exported to the web and Wonderland?
There's a few reasons. Unity is an amazing engine, especially for mobile. But the web is kind of like one of the 20th platform or something that they also support. And we believe that it's very necessary to optimize for the specific performance characteristics of the web. Optimizations that work on web don't really work on native, and vice versa. So that means we get a lot of performance out of the web. And another might be the workflow, the packaging times. To work in Unity with JavaScript, you cannot use the preview, so you need to do a full package, which takes 15 to 20 minutes. For Wonderland, it's like less than 1 second to see the fully packaged app in the browser. We made that a design decision when starting from scratch with the engine.
Thank you.
A question out there. And we have last question, and then we move on.
Hello, my name is Timur. I'm one of the developers of Minecraft Java Edition. My question is about, is it possible, performance-wise, to target proper big PC VR games with WebXR?
I believe absolutely. For Wonderland engine, we had an early focus on VR standalone, so you might be missing some like full screen shader effects, post-processing effects. We'll have those eventually, and I mean from scopes like 3D streaming, these kind of things, like large open worlds, absolutely. Just maybe with those effects, you'll like encounter a little bit of friction.
Thank you.
So let's give another round of applause to Jonathan and Timmy. Thank you very much, guys.